Yeah, I actually had a call for papers was open, and a coworker said, "Hey, Greg, you should talk about process dictionary." So a very inventive talk title was invented. So I get the unenviable slot of right after lunch when everyone's digesting a big meal. So hopefully I can keep you guys engaged and awake with a tale of arguments, of strong opinions, with information whispered in the shadows, and with mutants that are living in your beam right now. So people used to want to just squelch this information. You know, jerks like this on the Elixir forum. That was me about a year ago, and this was meant tongue-in-cheek even back then. But process dictionary is not something that gets talked about a whole lot. And since that time, I've been working employed full-time in Elixir, and I found myself in a situation where I'm going, I think I'll use the process dictionary for this, and that's what led me down this whole path. So first of all, I guess I want to thank my company, Seat Scouts, who's sponsoring my trip. We're a small startup that serves software services to ticket brokers, and we have lots of asynchronous tasks in the background, lots of third-party APIs that we pull and push from, and the whole Elixir has been an amazing tool in that space to kind of keep all the concurrency going. Also, we're hiring with a little caveat there. I think right now my coworkers are interviewing a React Native guy working on mobile apps, and my CEO told me this month, or told me this week, within about a month or two, we'll be looking to hire some Elixir developers. So if anyone's interested to hear more, we can talk later. So, here's the audience participation part of the talk. I warned you. How many people are familiar with Process Dictionary? Show of hands. How many people have actually written code that uses it? How many people are ashamed that they have? Okay. That's pretty much the same group. But let's go through, maybe I can address some of this shame. So for those unfamiliar, Process Dictionary is actually a key value store that exists in every process on the beam. I'm going to be using probably Elixir-specific terms here and there, but these are beam features, so it would be available pretty much, except for APIs, in any language that might be on the beam. This actually exists kind of alongside the heap of the beam and can grow as you add new terms to it. Well, the caveat is it's not garbage collected, so it can grow, but that memory is going to be allocated until that process exits. And the API, is pretty straightforward. You can get a key out of it, you can put a key into it, you can delete a key, and you can ask what keys are in there. The get keys version actually has an interesting arity 1 where you can give it a value, and it will tell you back the list of keys that have that value. I haven't figured out a purpose for that yet, but it's kind of good to know and have it in your back pocket in case you ever find a use for it. And then finally, you kind of process info, which is really not something that's production code. This is more debugging code, where you can actually peek into the internals of some other process. There's some caution about this, but you can get the dictionary of another process if you need to from IX console. One thing about that, because it's a mutable data structure, it gets copied and given to you, so you only get a snapshot in time. So that's the basic API. Here's kind of what it looks like in IEX. I'm writing a new pristine function I'm going to spawn, and all it does is a bunch of inspecting of the outputs, and I've colored them in blue. So we see if you do a get keys initially on a fresh process, there's nothing in there. You can put Lonestar ElixirConf in there, and notice the put returns a nil. I'll come back to that. Then you call get keys again. And now to a pure functional programmer, they're going to start getting nervous right now, because you've called the same function with the same arguments, and you're getting different results. So this is another management of state, mutable state in the beam. And that's kind of the core to so much of the contention around this. Then we can get the key out of it, and then we can also put and update that key. And interestingly enough, when you do a put, it returns to you the prior value of that key, or nil if it didn't exist. So that's why when we first put Lonestar ElixirConf, we get nil. When we put Lonestar rocks, we get ElixirConf. Similarly, I didn't put it on the slide, but if you do a process delete, the key returns to you the prior value, what the value of that key, the call returns to you the value of what that key was. So that's the basics of it. And let me show you now. This was, my situation. Oh, great! I can't. Okay, this will be fun. Oh, great. Later. Just try this tomorrow. There we go. Thank you. It's hard to read from that angle, actually. Oh, okay, look. I'm sorry to do this. I'm going to have to get my mirror displays thing going so I can actually see what's going on. All right, that's going to be much better. And the text is too large, it looks like. Okay, this would give us, okay, this was, okay, I mentioned that my company does a lot of data aggregation. One of the things we offer is sort of like accounting service. We get payment information, invoice information, and automatically reconcile this. So I have this example when we're importing a CSV file of a bunch of payment information. Now, in this case, it happens to be payment information from multiple of our customers. That's an export from a common third-party service that they use. And we're given this as sort of a take it or leave it format, so I have to kind of deal with what they give us. It's all sorted by transaction date. It's not grouped by customer like I would prefer it to be. But you see there on line 12, this is one case where they give us this login name that really is not meaningful to us in our system, but it can be mapped to the user ID in our system. And ultimately, this is what we need to do this CSV import properly. Now, part of the complexity here is we don't store this typically. We can sometimes have it in our local database. Sometimes it takes a remote call to actually do this mapping for us. The reasons are kind of hand-wavy and outside the scope of the talk, but that was the situation I was facing. And this CSV file can be hundreds of thousands of rows. My first thought was, let's group this together so I can process all of one customer's information at one time. But with hundreds of thousands of rows, I'd really rather not and just kind of take this as it comes. So this user ID for login name, oh, yeah, here's just a little mapping of what I do to each row. Nothing too exciting there. So here's what I've got, user ID for login name. And scroll down just a little, too far. Okay. I'm using the process dictionary like a little miniature cache here. So we look to see if we know what the value is, and if we don't, we call this potentially slow lookup, remote lookup call, and we get the value back. We put that in process dictionary, and we return it to the caller. And so that way, even though the different customers' login names are all interspersed as rows in these files, I only have to do this remote lookup once for each one of those. The nice thing about this is it's all contained in the one function. I actually show down here, I commented out, this was kind of the original version that I had, but take all the process dictionary out, and I've got something that is still correct. So because I had this sort of isolated, I'm kind of going, maybe I'm doing okay with this process dictionary thing. Or maybe I should feel bad about myself. So I did what anybody does in those situations, and go check on the internet and see what do they tell me about how I should feel about myself. And I learned something. I hate to break it to you, but there are some strong opinions out there, especially on process dictionary. So I want to present kind of both sides, and let's kind of go through these piece by piece and help us all gain a better understanding of what this is about and when we should and shouldn't use it. So this guy I call Mr. Cross. He just has this face that looks like he just says, no, no, no. And his argument, process dictionary, erases all the functional benefits we get. It should be removed from the language, and you should never use it. You can tell he feels really strongly about that because of all the exclamation points. On the other side, there's this guy I call Yes Man. You can tell he likes to say yes because he's wearing 3D glasses, of course. He tells us the process dictionary makes Elixir multi-paradigm, and that there's plenty of examples of it in the wild by responsible programmers, and you should use it whenever it's convenient. So, of course, as with any argument, there's pros and cons of both sides, and so I want to kind of go through a debunking phase, or at least applying that context and nuance that we so often find in internet holy wars. So, break it down piece by piece. So Mr. Cross says it erases the functional benefits, and Yes Man says multi-paradigm. So this is my chance to kind of say they both have a point and they both miss the point. For starters, we're not a pure language in the first place. I don't want to work in a pure language. A pure language is like a calculator. You give it a number and a formula, you always get the same answer back. You can't do interesting things. Anything involving I/O, anything that saves to a database, anything that talks to a remote service are all side effects. And you have to have side effects to have anything interesting. Imagine a video game that every time you ran it, it did the exact same steps. That would be a boring game. So even built-in core to the beam, the whole idea of process mailboxes, those are all about side effects. It's all about sending a side effect to some other place and having that worked on. So saying it erases the purity is totally, pointless because it wasn't pure in the first place. And we don't want it to be pure. On the flip side, multi-paradigm. Multi-paradigm, sounds great. I imagine, someone in academia wants to come up with, the perfect language that everyone can use in the way that they want, and, the one true language, and via all that, we can all find harmony together, And it sounds great in theory, but in practice, this multi-paradigm sort of language, you end up with a maintenance nightmare, because it's anarchy. Everyone does their own thing. Even in the same code base, you're going to find vastly different styles from module to module. I really want a community that says, this is the way we do things, and not just say, it's a free-for-all, we're going to refuse to make decisions. You want opinions. You want community leaders that have good opinions, and I think we've got that, and I'm really happy here. So it kind of comes back to the Elixir way, which we get from the Erlang way, and is we want to have most of our code be pure functions as much as we can. What we realize the reality that we have to manage state, and we want to isolate where we manage state and be able to reason about that in isolation from maybe all the processing code, or the processing code in isolation from the state code. There was an interesting discussion last night. The point was brought up that it seems like with Elixir, it's easier to refactor, particularly all that functional part of the code, because you're not managing the state. People have talked about refactoring things and it being easier than it is in an object-oriented system where the state is just spread out through your whole object tree. So that's my pontificating on the overall point of view of the language. And so the next point that they have, all right, Mr. Cross says this is so bad it should be removed. And Yes Man says, hey, it's everywhere, this is great stuff. So this led me down the path of let's try to find places where it's used. I want to find what I would consider responsible programmers, large teams, peer review, things that have seen a lot of production use, and let's look through the ways that they use it and help us decide what's responsible, what's irresponsible, is it everywhere, or is it few places. I didn't find a lot of things. I didn't look comprehensively, but here are some of the top ones that I found. The rand and the crypto modules in Erlang, which deal with seeding random numbers. Their APIs probably could have been written to take this random seed that you keep passing through and all the subsequent calls that you make involving random numbers, potentially passing it through 3 modules before you get to the module that really cares about the random number. But it stores it in the process dictionary, and it makes it a very convenient client interface. Because the people who are dealing with this stuff, They're writing games. They're writing behavior of the enemies in their video game. They're not worried about pseudo-random algorithms and how they need keys to provide their pseudo-randomness. So this is one use that it sits around in the process dictionary and just gets reused by those modules as they get recalled. We have proclib, which I'm no expert in, but it's part of OTP. It's kind of a layer down below the GenServer layer, kind of a library layer that it uses. It's responsible for launching all of the processes that actually get started via OTP style things. And one of the things it does is it sets these two process dictionary keys of $initial call and $ancestors. The initial call kind of tells you, which module and function and arity was used to call and create this process, which I think is primarily used for debugging. If you're sitting there in a console and you have a reference to a process, you can kind of look at this and kind of go, here's where I can find it in my source code and figure out what's going on. The ancestors, on the other hand, is interesting. It tells you which PID spawned which PID, and you can trace this back to the very first process that the beam's initialized with. This is actually useful and a very important way to OTP functionality. When a process terminates, it can walk the ancestors and see if anyone's trapping exits and who needs to be notified of the termination of that other process. I don't know for sure. I have some suspicion that process dictionary might have been invented for this purpose, but that's just my guess right now. I have to research that some more. In this case, you can almost call these metadata that's attached to the process. They're written once at startup and basically just kind of extra tag data on there. So that's how it uses the process dictionary. Amnesia was mentioned a little bit earlier in a question session. I'm no expert on it. I was reading a mailing list thread that talked about how the transaction identifier in amnesia is actually stored in the process dictionary during the course of a transaction. So that's something else. The API could potentially have taken transaction identifiers, and then you'd have to call different arity functions if you're in a transaction or not in a transaction, and it makes your client code much more complex. So this seems like a nice convenience situation for using the process dictionary. Logger. I think we probably all used Logger before. Not everyone knows, but Logger supports metadata. You can attach different metadata which is stored in the process dictionary. So you can do things like early on in like a Phoenix app and in a plug, you can figure out when you log a user in, check their session, or check their cookie, you can set their user ID in the logger metadata. And then in your logs, you can then filter out and just kind of see the calls that were made by that user and not be interspersed with all the other log messages, which really helps for debugging purposes. And again, this metadata could get passed around, but this would get passed around to potentially every call in your system, because you never know who's going to want to make a logger call that's 6 levels down the call chain. So again, you could argue that this is metadata about the process. It's just application-specific metadata and not necessarily OTP framework metadata like proclib was using. So seeing a few patterns emerge here. Gettext. This is probably the newest one I put on my list. This is an internationalization library that's used by Phoenix. I think there's been some really bright, responsible programmers who've developed it and code reviewed it. And it chooses to put the locale in the process dictionary. This is a similar situation, that you want all your views to be able to show the user a text in their preferred language. So you kind of store what their preferred language is right here in the process dictionary, instead of passing it through potentially 4, 5, 6 layers of your application. So this kind of gets back to that same sort of application. This is like an application. This is almost like this request-specific metadata. Ecto, probably taking some inspiration from amnesia. They store a transaction in a transaction. They will store database connection and some other keys and metadata about this, and when the transaction's over, they delete them. So here you have a very short-lived key. And again, like with these other cases, you could pass that in explicitly, but now you have different APIs if you're in a transaction or not. And again, the customer wants to write data to their database and don't care about transactional IDs and want to be messing with those complexities. So there's a real convenience factor here to the client programmers. And as I was looking at this, even IEX stores history in there. I don't know how this interacts with the OTP 20 history stuff. That may be kind of obsolete now. I'm not sure. But I just kind of saw it, that it was there while I was poking around, trying to look at process dictionaries. I probably could have found more if I had really looked, but these were the major things that stood out. So I see process dictionary being used. I wouldn't say it's plenty and everywhere. It is used for special purposes. There's things particularly like trapping exits, that if we removed it from the language, you'd lose that feature or have to find some other horrible workaround probably to try to support that. So I don't think it can be removed from the language, and I don't think it's everywhere. The answer is somewhere in between. Okay, let's show a little bit of, clear, respond, clear. There we go. Okay, so I've got, I wrote some helpers. This is like, because I hate to type in public as well as do math in public. I'm capable of both, but in public just makes it worse. So this is a pretty print process dictionary helper that I wrote. It just kind of lets us see what's going on here. This works via the process.info function that I mentioned earlier. So this is the current IEX process. We see that its ancestor was the PID 0630. Its initial call was the IEX evaluator init arity4 call. We can see IEX history here, which I guess my clear call is now put in there. It's got a little bit more metadata in the history than just a pure list. I skipped over the IEX evaluator, which was something surprised me when I saw this here, and I decided to look into that. You look in the Elixir source code. You can search for just that atom. It was pretty easy to find. It's used by pry. So when you set a pry breakpoint, this is how the code knows that, oh, I'm executing now in IEX, and I can know whether to prompt to say, hey, do you want to breakpoint here? It's the way it knows it can interact with the user. Elixir parser columns is another one I searched for, and this is way down in the elixir.erl file. This is actually Erlang code that uses it. I didn't dig enough to know what it does, but hey, it's there, and smart people wrote that, so I'm not going to argue about it too much. So let me show you a couple of things here. I've got rand call. Okay. So in underline is actually the code that my rand helper executed, rand uniform. So what we see here, it added the random seed key, which is a tuple with various parts to it. That's sort of the state management that the rand module needs to give you your random numbers. And now that's going to stick around in your process until it terminates. I can show you logger, where I called a logger.metadata where Lonestar Elixir. So we can look down. Logger metadata is now a new key in there, and it contains that keyword list that I passed in. And so any logger call can just look to see if that's in its process dictionary and output that with its logs messages. And I can show you a, great. I'll tell you what, I'm going to clear and then do a repo call. Still to, I don't know. Is that still legible? I mean, it's mostly stuff you don't have to read, but you can see right here what I did, the underlying code. I called a repo transaction and passed it a function that doesn't touch the database. It just prints the process dictionary while it's inside the transaction boundary. So this added 2 new keys there that are actually using 2 tuples, DB connection with a reference, and housekeeping information for a repo transaction. And we have the adapter and the pool as a separate that is directly to the database connection struct even. So that's a little bit of how to kind of look and see what's there and kind of how it's used in general. Let me see here. I need to go back. And there we go. Oh, wait a minute. Is this not going to work for me now? Am I all messed up? Computer. I don't have anything on this screen either. Here it comes. Okay, if I actually hit this, is it going to present there? No, we have it backwards. I apologize. Let's go back to what I knew was working. There we go. Okay, great. So, okay, back to our third part of our argument. We've reviewed kind of where process dictionary was used in different ways, different sort of characteristics for the way that different projects chose to use it. So now we get back to kind of the final advice section, where Mr. Cross is just like, nope, never use it. And yes, man, use it wherever, man. This is, be happy. Of course, the correct answer is somewhere in between. And so, kind of summarizing things, this is kind of, what I took away from this, is that our default answer should be don't use it. It's certainly something, if you're not used to functional programming yet, if you don't want to use this as a crutch, you need to make sure you understand how to write a reduce loop and use the accumulator properly. You should be able to do manual recursion. Don't use these things for just sort of loop variables. That's certainly not anything we saw in any of the examples there. So get functional programming into your brain before you consider process dictionary would be my first advice. Kind of pretend you didn't hear this if you're not at that level yet. And then when it does, you can review it. So try to solve your problem without it. Some of these other things, they had other solutions that usually involve passing around things to 4 or 5 modules, and you end up with these extra parameters that 90% of the functions don't ever use and just pass them along. So that was undesirable, and process dictionary ended up being a nice compromise for that. If you're writing a GenServer, you've got state right there. There's probably no reason to write a GenServer that also uses a process dictionary. Process dictionary is more useful to these like helper modules that get called indirectly from a GenServer call. If you do have like one like immediate neighbor module that you call directly that needs some state, consider just adding an extra key into your state and passing that in and taking it back from it. And it'd be just this opaque thing that your GenServer manages and hands along. And there's good precedent for even that behavior. That's actually how GenServer works internally. What we think of as GenServer are really our application callback modules. The actual GenServer code is a lower layer that actually has the run loop that passes the state as the parameter in its own recursive call. And there's just one element of that state that is sort of the application callback state. And so when that needs to call your application callback, it gives you that piece. So it's a good pattern to use. And that should be preferred over going to process dictionary. But when you find yourself removed from the GenServer code and your module really calls for some state, the safest way to use a process dictionary is as a write once constant sort of thing. It can be like metadata or even other sorts of data that you write it once, and you don't update it. There's no mutation. You're not setting a trap for future programmers to debug your code. This is pretty easy to understand and doesn't add that much complexity. Yeah. When you use process dictionary, try to centralize where the use of it is for the reads and writes. It'd be horrible to have one module read from it and then like 3 others write to it, or vice versa. So try to centralize that. Even, for example, in the logger, you call logger.metadata to set it. And even though you may be, 10 modules removed, when you call logger.debug, it's still logger code that's going to have the get and puts managed in it. If you go back to my CSV example, I had it all in one function, which is, I guess, the ideal, but just as long as it's at least in the same module and closely contained. Again, you're helping out the future maintenance programmer, which just might be yourself in a few months. And I mentioned in space and time, it's also nice, like those transaction identifiers. If you don't need it for very long, clean up after yourself, and now the time when this could be a problem to debug is limited in scope to just during a transaction. And that, again, helps the maintenance programmer be able to find their guideposts and not get caught up by this extra state. Because really, process dictionary represents extra state that's not a GenServer that's managing it. You still want to manage it centrally and treat it carefully and not set traps that are going to be hard to debug. Cautionary tale. I read an interesting story as on a mailing list as I was researching this stuff. Someone was in a situation where they were running really low on memory in their Beam and they weren't sure why, and so they connected a remote console to it, and they asked a process to give it, the dictionary to see what was in there, and it crashed the Beam. It ends up they had a whole lot of data sitting in the process dictionary, and because when you call process info, it copies that. I caution you against putting a lot of data in your process dictionary. We should keep that small and keep that self-contained. You can always go to some external cache, so, EATS even, or go to Postgres if you really need large amounts of data. So, next. All right, so going through all this, I kind of felt like process dictionary has kind of been this little, annoying little stepbrother of like macro club. You know what I mean here? Developers are interested in it, they want to know about it, but there's rules. And unfortunately, I didn't come up with anything really more creative than, the first rule of process dictionary club is don't do it, or if you're going to, do it responsibly. And I hope that we've got a better idea of what it means to do it responsibly. It's still treat your state carefully and try to give signposts to this is where things are happening that change state, and keep most of your program pure and functional. And I'm actually through this quickly, so we got plenty of time for questions. Thanks.
It was always my understanding with these kinds of things that you just have to ask yourself 2 questions before you start writing macros or using process dictionaries. Am I Jose Valim, or do I have a written permission from Jose Valim? Anyway, questions?
Okay, so you said like when you do random, it uses process dictionary to sort of seed, right? What process does it actually go into? Like if I call ran.whatever in my ran.uniform or something in my GenServer, is the seed stuck in my process?
Yes.
Okay.
It's in the process that calls ran.uniform. No, each process is going to have it separate.
This seems pretty trivial, but I mean, it's the same, this pattern, I don't know what else to call it, right? This idiom seems to be the same thing as like having the static portion of memory in an OS process, or depending on how you build objects, right? If you pass in constructor arguments that construct an object that maintains a certain state that it uses for all its method calls, right? And there's good ways and bad ways to do those things. The only thing that seems different than, say, OS process static memory space is it's dynamically addable, right? And yeah, that's about it.
Yeah, this will actually grow. but it doesn't get reclaimed until the process terminates. There have been people that have tried to write object-oriented ideas on Beam, and where basically your setters and getters are basically, putting and getting process dictionary entries. And then they hit a wall because the difference is a process in Beam is single-threaded. It is serialized. In object-oriented program, you can throw multiple threads at one object. So it doesn't get you very far. So it's similar, but I wouldn't use it the same way all the time.
Does the process dictionary have like a stable time or space complexity guarantee of any kind? Like, can I depend on it to be like, have the performance of an actual dictionary, or is it implemented with some non-public API?
I don't know enough about the low-level implementations, but I would expect it to be pretty stable. There's a book, was it Beam Internals, I think it was called, that I skimmed over recently, that goes into a lot more of that low-level detail. If you'll ping me, I can look that up and get you a reference to that later. I'm sorry? The Beam book, okay. It's a free book online, and it really does discuss the memory layout of all the processes at a very low level.
Can you give an example of when we might prefer using the process dictionary over creating a new ETS table or creating a GenServer to contain the state?
Okay. I can't put a hard and fast rule on it. I can throw my example in there that I did in a CSV file. My whole point was just to process this CSV file. I could have created an EATS table. It was an extra syntax I was going to have to go look up because I don't have it on my fingertips. Or as Chris was saying, just kind of make it work in IEX. So this was a lot easier and more straightforward. I was only storing one type of information in there. If you have larger types of information, maybe larger amounts of information, I would consider some other solution. I like thinking of this as, if you can make an argument that this is metadata for the process, process dictionary is a lot more justifiable.
No more questions?
In the front. Here come the hard ones for the end.
No, so the only thing I was going to add with the ETS comment versus, like, why wouldn't you use ETS table or versus the process dictionary was like the system limits for the ETS table is quite low by default. So if Logger used ETS, for example, it could piggyback off like what's the PID, it could check an ETS table that it created, but you would quickly exhaust the system limit for the maximum number of ETS tables. Yep, so I think that'd be the easiest answer. Like if ETS would work if it was something that wasn't, like a lot of processes weren't using. But like your example, if you had hundreds of thousands of processes storing that user ID, creating their own ETS table, that would exhaust the number of tables you could start.
Okay, thank you. Great. Oh.
I think just one comment. With the process dictionary, you make troubleshooting and debugging a million times harder. And I'm not sure I didn't hear it. I didn't hear you mention it. Because, it's, you're introducing a global variable and you don't know where the values change, so you basically cannot reproduce the bug, not knowing exactly what was in the process dictionary, which is something you don't
Definitely.
know.
It's something you shouldn't take, you shouldn't take lightly. I mentioned you don't want to set traps for debugging later, to try to keep these very contained, the reads and writes very close in time or even in the same function, to try to minimize those. But you're right, it introduces a new type of state beyond the GenServer state, and you have to be aware of that when you're debugging, certainly.
20 years of Erlang program, I used it once.
Okay.
When probably an hour before the deadline, I realized I needed the value down here, which was available up here.
Okay.
And so put it in the process dictionary, picked it up there.
Okay.
Checked in the code, worked.
I didn't find that in my list of responsible uses of it. Deadlines. Deadlines are not responsible uses, but certainly realistic ones, yes.
And then, as soon as it was checked in, I went in and fixed everything.
Okay. So Band-Aids. Band-Aids are another possibility, but pull them off.
Did you find any way to copy the logger metadata into spawn processes other than just knowing that it's in the process dictionary and copy it in? Because we had that problem with calling client libraries that spawn their own processes.
Yeah, that's something that I didn't actually get into. It didn't fall naturally into the narrative. Yes, that's another drawback to process dictionary is when you spawn other tasks. I also heard that complaint using gettext. If you're spawning something else that's going to generate output you want to show the user, you need to know what locale to do it in. And it really is an extra burden on every user of your system to know, hey, I've just got to copy these things into my other processes that I spawn if I care about keeping them consistent. I don't know if there's no magic way to, as far as that I've seen, to kind of, hey, copy this over. We've got one more back here.
Just a naive question. Since he says it's more like a global variable, I think of it if you're doing an ETS process, which is going to run for a very, very long time, but it's going to run only once. You want as fast as possible a variable, because if you were using it in another process, there's a communication, or if you're passing it through the stack, there's always a copy of that. So could you say only in very specific reasons where you're thinking this is a global and I'm going to do a long process and then I'm going to be done with it? Is that reasonable?
Well, that was one of the points. If you can keep it short-lived, I think you have more justification. There's always a gray area. Oh, well, okay, I thought you were asking for process dictionary. Okay.
I mean, my one little process.
Okay.
Going to run for an hour, it's going to do one.
Oh, okay, it's going to do one thing. So you've got something very self-contained. That sounds a lot like that CSV file I was importing, that it was just importing a CSV file. It was writing along the process that was actually managed down in Cowboy, through a web request, and it was doing one thing, and it was exiting. And I wouldn't need that again for a while. And an eats table would have worked for my situation. I didn't actually benchmark the two of them, but considering this was just like 3 lines of extra code that I put in, I was pretty satisfied with it, and thinking that there's fence posts here, and I'm not setting landmines for future debugging. So I always think of future maintainability when I'm writing just about anything. That's something that I've learned through hard knocks of writing really unmaintainable stuff and then having to maintain it. Try to set guideposts and not traps for yourself. That guides a lot of my design decisions.
Any more? Oh.
Is the process dictionary inherited anyway? If you spawn more processes, does that stuff get copied down into child processes?
No, it doesn't. That's what Luke asked a little bit earlier. That's one of the roadblocks. When you have roadblocks, it's a caveat. It's something you have to be aware of. Like if you have logger metadata and you're going to spawn a task, you kind of have to know to copy that logger metadata so you really have your log that's comprehensive. It's straightforward when you're just in one process, but when you start spawning them out, it's something you have to be aware of and copy explicitly.
If I don't see your hand, just shout. No more questions? Those are some good questions. Also a good talk. Definitely food for thought. Please give it up.